Hey guys, so we are going to talk about how to calculate the molar mass of a compound. Now that'll get you through the worksheet molar mass, and it should also help you with moles and atoms with compounds, okay? So, again, just to kind of review, I know how to go from atoms to moles, okay? 1 mole is equal to 6.022 times 10 to the 23rd atoms. That's Avogadro's number, okay? I can go back and forth between atoms and moles. Okay, I can even go back and forth between moles and grams, because if you remember, on the periodic table, that molar mass number, for example, beryllium is 9.01, that's how much in grams 1 mole of beryllium weighs. So I can go back and forth there. But again, remember, there is no way to go from atoms directly to grams. You have to go to moles in between, okay? So in the last video that I did, we talked about how if I have this many atoms and I wanted to find the grams, you have to step over to moles to get down to grams. Okay, so those are two-step processes. All right, so today we're talking about the molar mass of compounds, and I want to just review again molar mass. So if we look at the periodic table here, boron, I don't know if you guys can see that because it's kind of far away, but boron, the molar mass of 1 mole of boron is 10.81. The molar mass of 1 mole of carbon is 12.01. And these are in grams, okay? But what if I had something a little bit more complicated? So if I have this molecule, and I said, what is the molar mass of this molecule? Well, if I look at the periodic table, I can see that an oxygen has a molar mass of 16 grams. Okay, so 1 mole of oxygen weighs 16 grams. But what if I wanted to know this? Because if you see here, I don't have just 1 oxygen. I have 2 oxygens. So I want to know what 1 mole of all of that weighs. Okay, so the way that you do that is you just take the individual pieces and you add them together. So I know that 1 oxygen weighs 16 grams. I know that 2 oxygens are going to weigh 32 grams. Okay, because there's 2 16-gram oxygens there. Okay, what about if I have H2O? So I know that oxygen weighs 16 grams. 1 mole of oxygen weighs 16 grams. And looking at my table, I can see that hydrogen weighs 1.01 grams. Okay, so a mole of hydrogen is 1.01. But I don't just have 1 hydrogen, I have 2. So I have to put that one on there twice. Okay, so you're just adding these up. So what you'll end up with is that 1 mole of water is 18.02 grams. Okay, and that's the only new thing. We're doing the atoms to moles to grams just like we did in the last assignment. It's just now we're using compounds instead of single atoms. Okay, so let's practice a couple of these. Let's say how many atoms are in 53 grams of water. Okay, so I'm going to put it in my T-chart. I know that I have 53 grams of water. Okay, now I'm trying to get to atoms, but I can't go from grams to atoms. I have to go from grams to moles. Okay, but the problem is there is not an H2O element on my periodic table for me to go and figure out how much a H2O weighs. So I have to individually calculate how much this weighs. So the way that I do that is I say H, which is 1.01, plus H, which is 1.01, plus O, which is 16.00. Okay, so if I add that all together, I get 18.02. What that means is that 18.02 grams is equal to 1 mole of water. And this is the conversion factor that I'm going to use. So if I have 53 grams of water, I need grams to go down here. So I'm going to put my 18.02 grams down here of water is equal to 1 mole of water. All right. Now, my grams of water will cancel. What I have left is moles, and I'm not looking for moles. I'm looking for atoms. Okay. So 1 mole of water is equal to 6.022 times 10 to the 23rd atoms. Okay, my moles will cancel, and I'm left with atoms. That's what I'm looking for. So I can go ahead and plug this into my calculator. So I've got 53 times 6.022 times 10 to the 23rd. Then I'm going to hit enter because I don't want to mess anything up. And then I will divide by 18.02, which gives me this. Excuse me. So I've got 1.771 times 10, and it says e to the 24th, times 10 to the 24th atoms. So what that means is that if I have 53 grams of water, I actually have 1.771 times 10 to the 24th individual atoms in that sample. Okay, let's do another one. So how many grams are in 5.5 times 10 to the 24 atoms of CaNO2 to the third? Okay. So I'm going to start with what I know. And I know that I have 5.5 times 10 to the 24th atoms. Okay? Now I'm going to have to go from atoms to moles because I can't go atoms to grams. All right? So I know that 1 mole is 6.022 times 10 to the 23rd. Okay, so my atoms will cancel, and I'm left with mole. I'm not looking for mole. Okay, so 1 mole, I'm looking for grams up here. Okay, but I can't just say calcium, or I can't just say nitrogen. I have to figure out how much that whole entire compound weighs. All right, so what I need to do is I need to add up a calcium, and then remember this 3 means that it distributes like that. So I actually have 3 nitrogens, and then I actually have 6 oxygens. Okay, so I'm going to go in here, and I'm going to add all that up. So I got calcium. Let me double check that I'm doing that right. Yep, this is just going to be a gross number. Okay, sometimes it's just like that. So my calcium is 40.08. Okay, and then I have 3 nitrogens. Now nitrogen is 14.01. I got 3 of them. Okay, and then I need to add my oxygen, which is 16, and I got 6 of those. Okay, I'm going to do that in my calculator real quick. That's 48. And that gives me 178.11. Okay, so 1 mole of calcium nitrate is going to equal 178.11 grams. Okay, so I'm going to go ahead and plug all this in. So I've got 5.5 times 10 to the 24th. I'm going to hit enter because I don't want to mess anything up. All right, I'm going to multiply that by 178.11, hit enter, then I'm going to divide that by 6.022 times 10 to the 23rd. And I get this number. Okay, so my end result is 1627. Because again, that's a 6. That's going to make it round up. So 1627 grams. So I was looking for grams. I ended with grams. Everything is square. So I'm going to turn y'all loose on your assignment. Hit me up if you have any questions. It is honestly just the same as the one from the day before, except for you have to add up the mass of the whole compound now instead of just the individuals. So let us know if you need anything. Yeah, just let us know.